Hello friends, today we are going to talk about chemical reactions and equations. So let's look at what all are the different things which will comprise of this particular exercise. So we'll start with understanding what is a chemical reaction, how do we identify a chemical reaction, post which we will look into how to balance a chemical equation, and lately we will also look into what all are the different chemical reactions which are currently possible. So let's look at the first thing in our agenda, which is what is a chemical reaction. So let me just write it down. So our first topic is what is a chemical reaction. So for this, let's look at the definition of a chemical reaction. A chemical reaction is a transformation of a chemical substance into another chemical substance. So let's write it down and see each of the key words in this particular definition and understand them better. So it's called transformation of a chemical substance into another chemical substance. So let's underline the key terms in this equation. The first key term is chemical substance and the second key term is transformation. Let's talk about each of this term in detail to understand them better. So the first term we used is a chemical substance. What is a chemical substance? A chemical substance is a matter which has its own chemical composition and physical and chemical properties. Let me give you a very simple example of this. The drinking water or any kind of water which we use is H2O, which is contains two atoms of hydrogen and one atom of oxygen. So irrespective of whether you take water from a river body or any other water body, or you create water in a laboratory environment, you still have water which comprise of two atoms of hydrogen and one atom of oxygen, right? So H2 plus O2 gives H2O. So this is water, which is a particular chemical substance. So how is this water created? So we'll talk about this when we look into transformation. So the second key term which we used is called transformation. Transformation is change of a chemical substance which can be either an element or a compound into another element or compound. So for example, if we look at this one, we have hydrogen and oxygen elements which when combined together gives another element, another compound which is water, H2O, right? So we look at each of the properties of hydrogen and oxygen and the properties of water. We will see that the physical and chemical properties of hydrogen and oxygen are very different from the properties of water. So this is a chemical reaction, a very simple chemical reaction, and it has the transformation of hydrogen and oxygen into water. So I hope you are able to understand the definition now, which is transformation of one chemical substance or more chemical substance into another or more chemical substance. So there can be two chemical substances or three chemical substances which are getting converted into 2, 3, 1 or as many of the chemical substances. So now let's look at how do we identify whether it's a chemical reaction or not. What are the signs of a chemical reaction, or how do you understand whether there has been a transformation? So let's stop this and look into our next topic, which is how to identify whether a chemical reaction has happened or not. right? So our topic is identification of a chemical reaction, or the different signs can understand a chemical reaction. So let me take a very simple example for all of us, right? When we burn paper, what happens? The paper converts into ash, and we also see smoke. So what does that mean? So let me explain in a chemical reaction term what happens when paper gets burned. So paper is basically cellulose, which is C6H10O5 N times. So this is our paper, right? Paper is essentially a multi-chain of glucose, which becomes cellulose, and then when we burn it, which is application of heat, what happens is paper turns into ash, which is carbon. It also turns into carbon dioxide, carbon monoxide, and water, all of which is present in the smoke which we get at the end of the burning of paper, and carbon is basically the ash. So I hope you understand what happens when a paper burns. It converts into ash and smoke. The ash is primarily carbon, and the smoke is primarily carbon dioxide, carbon monoxide, and water. So this is a chemical reaction. So now in this particular chemical reaction, now let's look at how do we identify a particular chemical reaction. So paper or cellulose is in a solid state. The ash is again in a solid state. The carbon dioxide, carbon monoxide, and water are all in gaseous form, right? So now this leads to the first identification mark, which is change of state, right? So what happened is a solid substance when burned converted into another solid substance plus 2 or 3 gaseous substances. So this is the change of state. By the change of state, you can understand it's a chemical reaction. The second key point is change of color. So let's look at change of color and how does. So let's take another example to understand change of color better. So I'm going to wrap this up and let's again write these points to see what is the example we are going to take for the change of color. So the first point we understood was change of state because of the burning paper, right? The second is change of color. So let's take a very simple example. It's a laboratory experiment which you can do in your school laboratories, where you can dip an iron rod in a copper sulfate solution and see what happens to the iron rod and the copper sulfate solution. It's a very interesting experiment which I would like you guys to try in your schools. So let's look at this particular example. Iron is Fe, which is solid, plus you put copper sulfate solution, which is aqueous form or liquid. What happens here is it becomes iron sulfate, right, aqueous, plus copper solid. So what happens here? The copper sulfate solution is initially blue in color, but when you dip an iron rod, so this is our iron rod, when we dip this iron rod in the copper sulfate solution, the copper sulfate solution turns into light green. At the same time, we will see that the iron rod has a coating, has a brown coating on iron rod. There is a brown coating on the iron rod which is due to the copper. So this is another chemical reaction where we can easily find out that there has been a change of color from blue to light green, because copper sulfate solution, in the copper sulfate solution, copper gets displaced by iron and it becomes FeSO4, which is light green in color. So let's look at the third one. The third key point is the evolution or absorption of energy, which we can again see as this is when it is energy is absorbed and energy is evolved. So evolution is called exothermic reaction and absorption of energy is called endothermic reaction. We'll talk about this in a little bit more detail. So whenever a chemical reaction happens, there is a high possibility of it either requiring energy for the chemical reaction to happen, or at the end of the day when chemical reaction is done, we will have energy produced. So this is called exothermic and the other one is called the endothermic. So let's look at simple examples to understand this. In the photosynthesis process, you would have learnt in your school days the photosynthesis process by which the plants make food, right? So photosynthesis requires energy. So there is an absorption of energy here. And hence it is a endothermic process. So what happens in a photosynthesis reaction? You would remember from your previous classes that in photosynthesis what happens is the carbon dioxide and the water combines together to form glucose, right? So it is basically CO2 plus H2O forms C6H12O6, which is glucose, in the presence of energy. And this energy comes from where? This energy comes from sunlight. So this is a simple example of an endothermic reaction where energy is absorbed to make sure that a chemical reaction takes place. We'll now talk about the exothermic reaction. I think the board is filled, so we'll rub it again and we will write the third equation about what is an exothermic reaction. So we just now saw the absorption of energy or an endothermic reaction in terms of photosynthesis. Can you think of an exothermic reaction which happens, which is similar to the process or the opposite of the process which happens in plants? So the example here is the respiration process which happens in our body as well as other organisms. So what happens in respiration? When the respiration happens, we need energy to carry out our body functions. So what happens? The glucose which is present in our body breaks down and produces energy. So that's how you get energy for all the work you do, right? So let's look at this particular example of exothermic reaction. So glucose is present in our body because we eat a lot of plant stuff or any other products which have energy. Now what happens is this glucose, when present in the presence of oxygen which we breathe, it breaks down into carbon dioxide and water plus energy. Now you would remember that when respiration takes place, we breathe in oxygen. So that particular oxygen, when combined with glucose present in our body, breaks down into carbon dioxide which we exhale, and then water which is present in our body or comes out as sweat, and then energy is produced which we can use to carry out our day-to-day routine, right? So that is a simple example of an exothermic reaction. So I hope you would have understand the evolution or absorption of energy in a chemical reaction. So we have seen this equation in the reverse form where energy was used to create glucose in photosynthesis, and now we are seeing the opposite reaction in respiration where energy is being given out by using glucose in addition to oxygen which we breathe in. So let's look at the fourth identification post this. So let me just rub it and then we will look into the fourth identification. The fourth is evolution of gases, right? So some of the previous examples which we see, there have been evolution of gases. For example, in respiration, we saw that the carbon dioxide is exhaled by us, so that is the evolution of gas. Let me look at some other examples also. For example, CaCO3. I hope you know what is CaCO3. It is calcium carbonate, right? When calcium carbonate is heated, this delta sign is for energy is given, which means there was heat energy given. So it converts into calcium oxide plus CO2. Calcium oxide is called quicklime and CO2 gas is given. So you would have seen when calcium carbonate is heated, there are some bubbles comes. So these bubbles are carbon dioxide which is given out. So we are going to talk about one example of evolution of light as well as evolution of sound. So first one, let's look at evolution of sound. When zinc rod is dipped into hydrochloric acid, what happens is it gives a popping sound. So let's write this equation and understand what happens. So zinc, when combined in HCl or dipped in HCl, it becomes zinc chloride and it leaves hydrogen gas. So the hydrogen gas which is leaving gives that popping sound to this mixture. So let's look at the next one, which is evolution of light. So when magnesium ribbon, right? When magnesium ribbon is burnt, it gives a strong flame or light, which means that the magnesium when combined with oxygen is becoming magnesium oxide, MgO. So I hope you understood all the different ways we can look into and identify whether a chemical reaction has taken place or not. So now when we have understood the 5 key elements of a change or how to identify a chemical reaction, first is change of state, second is change of color, third is evolution or absorption of energy, fourth is evolution of gases, fifth is evolution of sound and light. So now let's go to the next topic, which is understanding how to balance a chemical reaction. Prior to this, we will just understand what all are the different components of a chemical reaction, and then we will go into balancing a chemical reaction. So now we move to the third part, which is balancing the chemical equation. So let's look at how to balance a chemical reaction. So for prior to balancing a chemical reaction, let's look at what all are the different terms which are used in a chemical reaction. So let's take a simple chemical reaction, A plus B forming C plus D. A plus B are either elements or compounds which are taking part in the reaction, and hence they are called reactant. C and D are something which are getting formed at the end of the reaction and are called products. The arrow denotes the direction of reaction. In addition to this, what else we can signify in a particular chemical reaction? We can also denote each element with respect to what is the chemical state. For example, whether it's a liquid, solid, gas or aqueous, which means it is a solution in water. So we can talk about that. We can also write what color the particular element or compound is in. So for example, in the previous example which we took, where iron is put into copper sulfate solution, which is blue, so you can write the blue color there, and then it is getting turned into ferrous sulfate, which is again light green color. So you can write the colors and identify them. So the two things which are getting started at the end, started at the reaction, are called reactants. At the end of the reaction, you make products, and the arrow shows the direction of reaction. You can also put the state like this. Probably this is a gas, so G, and this is again a solid, like this. So just wanted to explain you how to denote a particular chemical reaction and what all are the different terms before we start with balancing a chemical reaction. So now we have understood what is a reactant, what is the product, what does the arrow signify. Now let's go to balancing a chemical reaction. So let me look at a chemical reaction and understand how to balance that. So let's take a simple reaction of propane gas burning. Right? This is a process which happens in the petrochemical industry. You use a lot of propane gas in a lot of other industry, and this gas burns. So propane gas is denoted by C3H8, and it burns in the presence of oxygen, and it forms carbon dioxide, and it forms water. Right? So the first rule to balance a chemical reaction is that you cannot change the composition of an element or a compound. For example, O2, if you need one more atom, you can't make it O3. This is wrong. Similarly, C3H8, let's say you only have how many atoms here? 2 atoms here, and you have 8 atoms. So you can't change it to C3H2. This is also wrong. So you cannot do while doing a balancing of chemical reaction. So let's look at how do you balance a chemical reaction, and also understand why balancing of chemical reaction is important. So why does we have to balance a chemical reaction? That is on the basis of law of conservation of mass. The law of conservation of mass states that in a chemical reaction, the number of atoms or of a particular element in a compound or element on the reactant side is equal to the number of atoms on the product side. So, for example, A plus B plus D, the number of atoms of A, let's say it is 3 and this is equal to 4. So C plus D will have total of 7 atoms, right? And each constituent element will again have the same. So let's say in this example here, element A had 3 atoms and B had 4. So here also the constituent element A will have 3 and B will have 4. So let me give a very simple example here. So this particular example which we are looking at, C3H8 plus O2 forming CO2 plus H2. Now let's look at how do you balance a chemical reaction. Since we have understood that it is important to balance a chemical reaction, because in a chemical reaction conservation of mass is one of the key principles. You cannot have a reaction where 3 atoms are giving rise to only 2 atoms on the product side. If an element A has 3 atoms, it has to have 3 atoms on the product side. So let's look at this particular equation. So it has 3 elements: carbon, hydrogen and oxygen. Now let's look at what is the situation on the reactant side and what is the situation on the product side. So carbon on the reactant side has 3 atoms, right? And carbon on the product side has 1 atom. Hydrogen, whereas, has 8 atoms, and on the product side it has 2, and oxygen it is 2 atoms, and on the product side it is 3. So clearly we can see that the number of atoms for each of the element on the reactant side and product side are different. They are not the same. So let's see how to make that same, right? So for example, we will start with the element which has the maximum number of atoms. So which is here hydrogen. So hydrogen in the reactant side has 8 and on the product side we have only 2. So how do we make 2 equal to 8? So if we multiply 2 into 4, it becomes 8, right? So let's put a 4 here and see what changes it brings to the equation. So now we have 8 here and 8 here. Now let's look what other changes it has brought. So now the total number of oxygen here is 4 into 1 is 4 and 2. So total it is 4 plus 2, 6 atoms, right? So now you have 6 here and you have only 2 here. So what do you need to do? So you need to multiply this 2 into 3 to make it 6, right? So let's put it like this. So here you have 3O2, which makes it 6. Now let's see what other changes it brings to the equation. So you have 3O2 here, which makes it 6. You have O2 plus 4O2, which is again 6. Now the last part of the equation is carbon. Carbon here has 3 atoms, whereas on the other side, product side, it is 1. So what if we multiply this 1 into 3 to make it 3? So let's put a 3 here and then see again the equation. So now the carbon is 3 on the product side as well as the reactant side. But because we added a 3 here, the number of oxygen has changed into 3 into 2 is 6 and another 4 into 1, right? So it is 3 into 2 plus 4 into 1, which is equal to 6 plus 4 is equal to 10. So let's write it 10 here. So now let's look at this equation again. So you have 3, this one is right. You have hydrogen 8 and 8, that's also fine. But what we see is the number of oxygen has become 10 here, but here 6, right? So what can we do? So we understand each hydrogen element has 2 atoms. Since it's O2, it is 2 atoms. So if we multiply 2 atoms into 5, it becomes 10 atoms, right? So what we do here is, to make it 10 atoms, we change this 3 into 5. So that means 5 into 2, it becomes, instead of 6, it becomes 10. So now let's look at this equation. C3H8 plus 5O2 giving 3CO2 plus 4H2. Now if you see this equation, the number of carbon on the reactant side as well as product side is equal to 3. The number of hydrogen atom on the reactant and product side is equal to 8. And the number of oxygen atom on the reactant as well as the product side is equal to 10. So now we can say this reaction is a balanced reaction. We have not changed the chemical composition of any of the element or compound. So for example, oxygen is still O2, it is not O3 or anything else. Similarly, carbon dioxide is CO2 and not CO, which is carbon monoxide. H2O is kept as H2O and not H2O2, which is hydrogen peroxide, right? So we are not changing the chemical composition, but just multiplying it to say that instead of one molecule, we have 2 molecules of oxygen. Similarly, instead of one carbon dioxide molecule, we have 3 molecules of carbon dioxide. Similarly, for water, instead of 1 molecule, we have 4 molecules when combined. So this equation, we have, if you have to read it, it is 1 molecule of propane when reacted with 5 molecules of oxygen gives 3 molecules of carbon dioxide and 4 molecules of water. So that is how you will balance a chemical reaction. So the first rule of balancing is you cannot change the chemical composition. Let me repeat it once more. You cannot change the chemical composition of a particular element or a compound. The second rule is when you start balancing, always start with a particular element which has the maximum number of atoms inside it. So now let's also look at some other examples with respect to balancing chemical equations. So what I would like you guys to do is write down the next set of equations and we will try to solve them together one by one. So let me wrap this up and then we will write a set of 5 to 6 different equations and we will try to balance them. So let's start that. So we'll start with a very simple example, which is the formation of water. So let's look at H2 plus O2. How does it get balanced? H2 plus O2 forms H2O. So this is our first equation which we are going to do, right? So let's look at this particular example. So how many hydrogen you have? You have 2 hydrogen. You have hydrogen and reactant as this. Let's call reactant as R and product as PD. And let's see how many atoms are there. Here you have 2, here you have 2, here you have 2, but here you have 1. So now what do we do? This is the only part where it is not balanced. So let's make this balanced by putting a 2 here, which will make sure that the number of oxygen becomes 2. Right? So you have 2 oxygen here and 2 oxygen here. But now we see that the number of hydrogen has changed from 2 to 4. So let's make this change here as 4. Now post that when we look at it, now here it is 4 but here it is only 2. So we need to change this. So what do? We multiply the H2 with 2 to it became 4. So now hydrogen is 4, oxygen is 2. Now we have a balanced equation in terms of hydrogen and oxygen combining together in the presence of heat to form water, right? So that's the first example. Let's look at another example and let's see how much time we will take to solve that. So another example is iron plus oxygen forming Fe2O3. So I'll give you another 10 to 15 seconds to do this one and let's see whether you can solve it by yourself. So meanwhile I'll just talk about what does this equation means, that when iron gets corroded in the presence of oxygen, it forms rust. So this is an example of corrosion, right? So when corrosion happens, iron gets oxidized to become an oxide, right? And because of that, it is corrosion and it actually causes harm to lot of iron artifacts which we use, including big ships, to anything which we have in our house which is made up of iron. So now I hope I have given you enough time to solve this problem. So let's look at how to solve this. So Fe plus O2 forming Fe2O3. So we have 2 elements Fe and O on the reactant side and on the product side. Let's look at what do we have. On the reactant side we have 1 atom and here we have 2, and here we have on the product side we have 2 Fe and 3 O. So let's look at the biggest one, which is 3, right? So we have 3 oxygen here and we have only 2 oxygen here. So if you multiply this with 3 and this with 2, it will become equal, which is 6, right? So let's put a 3 here and put a 2 here. So now we have made this equal. So we have 6 here and 6 here. On the reactant side and on the product side, we have the same number of oxygen. But now what we have is the number of ion on the product side is equal to 4 atoms, whereas reactant side we have only 1. So if you multiply this 1 into 4, it will become 4. Right? So it's 4 here and 4 here. So 4Fe plus 3O2 forms 2Fe2O3. So this is how iron oxide is formed, which causes corrosion and rust for our artifacts. Right? So I hope you have understood how balancing of chemical reaction works. We will look into a couple more examples which are a little bit more detailed to see how can you solve these ones. Right? So the next example we are going to talk about is the respiration example. Respiration. So we breathe and we have energy, which is glucose which produces energy in our body. So how does that work? So glucose is basically C6H12O6, which is when combined with oxygen gives us carbon dioxide and water and produces energy. Now this is the energy which makes you help write the exams, crack the codes. So let's look at how this process works, right? So now if we see the total number of elements on the reactant and product side, you have carbon, you have hydrogen and you have oxygen, right? On the reactant side and on the product side, let's look at how many elements. So let's look at each of the element and see how many atoms are there. So first carbon, we have 6 carbon here. We have only 1 carbon here, right? Next we have 12 hydrogen here, but we have only 2 hydrogen here. We have total oxygen 6 and 2 8 oxygen, and here we have O2 and 1 3, total of 3 oxygen, right? So how do we make sure that we balance this? So let's look at the highest one. What is the highest number of atoms here? Hydrogen, which is equal to 12, but here we have only 2. So how do we make 2 equal to 12? Multiply into 6, it becomes 12. So we will put a 6 here. Okay? So when we put a 6, it becomes 12. So now it's a 12 here. But with this change, it is not only changing hydrogen, but it is also changing the number of oxygen. So we have total number of oxygen here is 6 oxygen here and 2 oxygen here. So we have total of 8 oxygen. Right? So we have 8 oxygen and 12 hydrogen. Both balanced. What is not balanced? The carbon. So let's look at how to balance the carbon. So the carbon is 6 here and here it is 1. So if you multiply with 6, it becomes 6. So let's look at this and put a 6 here, and also let me make this arrow a little smaller and put a 6 here, right? So now we have 6 carbon, but what has also changed, because it's not just carbon, it is carbon dioxide. So there is oxygen which is also getting multiplied by 6. So 2 atoms of oxygen are getting multiplied with 6. So it becomes here now 12 atoms of oxygen, right? And here it becomes 6 atoms of oxygen. So total number of oxygen atoms we have is 18, right? So now this has changed from 8 to 18. But here we have only 8, which is we have 6 here and we have 2 here. If we try to change this part of the equation, then it is going to add more carbon and more hydrogen. But if we are going to change this only, then we will not have any increase in carbon and hydrogen, and our equation will get balanced. So how do we do it? So So out of 18 we have 6 here. So we have 18 minus 6, 12 atoms remaining, and each oxygen molecule contains 2 atoms, right? So 12 divided by 2 is, we need 6 oxygen molecules. So if we put a 6 here, then it becomes 6 oxygen plus 12 oxygen, total of 18 oxygen, right? So now look at this equation. Is this equation balanced? So we have 6 carbon here and we have 6 carbon here. We have 12 oxygen here and we have 12 oxygen here. We have 6 oxygen here and 12 oxygen here, total of 18. Similarly, we have 12 oxygen here and 6 oxygen here, so total of 18. So now, if we see, this equation is balanced and we have solved this problem. We'll look at couple more examples in some time. The next example we are going to look at is the combination of sulfur and fluorine to form sulfur hexafluoride, SF6. So sulfur is 8 and F is 2. So S8 plus F2 forming SF6. So let's look at this one. So we have sulfur and we have fluorine and we have reactant and we have products. Let's look at how many of. So sulfur here is 8, here it's 1, and here fluorine is 2, and here it is 6. So let's look at the biggest atom, biggest number of atoms, and that is for sulfur. So now we multiply 1 into 8 to get 8. So 8 SF6, right? So but when we multiply with 8, it is not just sulfur which is getting multiplied, but 6 atoms of fluorine are getting multiplied with 8. So it becomes 8 6 are 48, right? So let's write it once more. The number of atoms on this side, on the reactant side and the product side. So here you have 8, here you have 8, 8 6 are 48, and here you have only 2. So what do? So you multiply each atom, each molecule of fluorine which contains 2 atoms into 24 to get 48. So 2 into 24 becomes 48, right? So here you have 48, so you make it 24 here. So S8 plus 24F2 makes it to 8SF6, sodium hexafluoride, right? Sulfur hexafluoride. So what we are looking at is 8 atoms of sulfur plus 24 atoms of fluorine form sulfur hexafluoride. Now let's take the last example where we are looking at Na plus water for forming NaOH plus H2. So we have 3 elements here, Na, H and O, right? So we look at the reactant side and we look at the product side. So on the reactant side we have 1, we have 2 hydrogen atom, 1 oxygen atom. On the product side we have 1, we have 3 hydrogen atom and we have 1 oxygen atom, right? So we see that sodium and oxygen are balanced. The only thing which is not balanced in this equation is the number of hydrogen, which is 2, 3. So how do we make sure that the number is same? So we look into, here it is 3 and here it is 2, right? So if we multiply, so here we have one H2 molecule. So obviously if we put a 2 here, it becomes 4. But if we just put a 2 here, then what happens? So the total number of hydrogen atom now here is 4, right? And if we put another 2 here, it again becomes 4. So we can, instead of putting 3, now we have 4 here and we have 4 also here. Let's look at the other. So now with this, it is not just changing the number of hydrogen but oxygen. So oxygen instead of 1 is 2, and if we put it here, why we didn't put the number 2 in front of H2? Because if we are going to make any change on hydrogen here, it is going to change oxygen. So it is better to change something which has oxygen and hydrogen both rather than something which has only hydrogen. So now it becomes here also 2. Now the last thing which we have is the number of sodium has changed here from 1 to 2. So we can also add another 2 here to make it equal. So now we have 2 sodium on both sides, 4 hydrogen and 2 oxygen. So now the equation is a balanced equation. So these were some of the examples, close to 5 or 6 examples which we looked into to solve and understand how to balance a chemical reaction. I hope with this you would have been able to solve by yourself how to balance a chemical reactions, and we will be able to do lot more exercises when at the end of the sessions we will give you a question booklet which will have lot of such problems for you to solve. So with this we will end today's session. In the second part of the chemical reactions and equations, we will look into all the different kind of chemical reactions which are present, right? So we will start with the last part of the topic, which is looking into all the different kind of chemical reactions, starting from combination to displacement, double displacement, reduction reaction, oxidation reaction, redox reaction, etc. Don't get worried with these many terms. We will talk about each one of them in detail, and we will explain each one of them in terms of how does it work, what is the reactant, what is the product, how does the whole process works. So let's talk about that in our next session. Thank you very much for everyone for listening to this, and I hope you were able to learn something new today. Thank you very much.